All right, ladies and gentlemen of Algebra 2, this is Unit 12.3, and we're talking about what is probability. Probability, in a nutshell, is going to be a fraction, and that fraction is going to be basically what you want to have happen over everything that could happen. So the probability of a success or something you want to have happen in any event is going to be the number of successful outcomes over the number of total possible outcomes. So basically, it's a fancy way of saying, what do you want to have happen over everything that could happen? Okay, down here a lot of times this is where you put your sample space, right, which is your number of things that could happen. All right, the probability of an event always occurring is always between 0 and 1. Okay, it's always got to be a fraction between 0 and 1. The closer that the probability of an event is to 0, the less likely that the event's going to happen. The closer probability of an event to 1, the more likely it's going to happen. All right, so if you hear people say that there is a 0% chance of something happening, that means there is absolutely no way it's going to happen. If you hear 100%, well, as a number, that is 1, so that means it is absolutely going to happen. It is a foregone conclusion. So, a bag contains 4 marbles, 3 green marbles, 6 red marbles. Suppose you reach in the bag and draw 1 marble, find the probability that that 1 marble was green. So, out of 4, 3, 6 marbles, so out of 13, how many of them are green? 3. There's your probability. Green over all marbles. That is what you're looking at. So, second one. Suppose you reach in the bag again and draw 1 marble. Find the probability that 1 marble was not red. So, I'm going to imply that I put the green one back. So, I'm back to 13 total marbles. But I want the probability that it's not red. So, not red means it can be blue or it can be green. So, there's 7 blue or green marbles out of 13. There's my probability. So what's the probability of selecting 2 vowels from the word algebra? So now 2 implies that I'm not putting 1 back, so this is going to be kind of without replacement. So what I need to look at is kind of, first off, how many vowels are there? And then what's the probability I pick a vowel the first time? And the probability I pick a vowel again. So there's 1, 2, 3 vowels. So the probability I pick a vowel the first time was going to be 3 out of 7. Now I've already picked that vowel, so that vowel's gone. So there's 1 less vowel, but there's also 1 less letter. So the probability of me picking another vowel is going to be that. All right, so I've got to pick a vowel and pick another vowel. Well, there's 3 vowels to start out of 7 letters. Once I pick out that vowel, say I pick out this first A, well, that leaves me with 6 letters left and 2 vowels left. So that's going to be my probability. So 6 over 42 when I multiply that, or 1/7. That would be my probability of selecting 2 vowels from there. So Julie has a collection of 32 albums on her iPad, 18 R&B and 14 rap. As she is leaving for a trip, she randomly chooses 6 albums to make a new playlist. What is the probability that she selects 3 R&B and 3 rap? So you're multiplying a little bit again because this and is in here. So I look at what's the probability that I select 3 R&B and 3 rap. So now there's a couple different ways you can do this, okay? So now since I'm going to be multiplying, here's what I'm going to start with. So there are 32 albums total. All right, 32 albums. What's the probability I select 3 R&B and 3 rap? So let's start with R&B. So the probability I pick R&B first is going to be 18 out of 32. Now the probability I pick R&B again. Well, I've already picked the first one. I'm not going to pick it again, so that's going to be 17 out of 31. And the probability I pick R&B again is going to be 16 out of 30. So now there's my 3 R&B. So now I got to jump over and pick three rap albums. So there's going to be 14 out of 29. And this is each album. Once I take it away, I'm not putting it back. I'm not using it twice. So that's going to be times 13 over 28 times 12 over 27. So it's 3 rap albums followed by, or 3 R&B albums followed by 3 rap albums. So now another way to kind of think about this, and it kind of goes back to the previous section. This is a combination of combinations, and here's what I mean when I say that. So when I'm picking the R&B albums, I'm picking 3 R&B out of 18. So, but order doesn't matter. So it's kind of like I'm saying 18, choose 3. And for the rap albums, I'll come over here on the right. That's going to be 14, choose 3. All right, this is going to be the possible ways I can pick 3 albums from R&B and 3 albums from rap. But that's not going to give me a probability. That's just going to give me a total number of ways I can do it. The probability is going to be these two multiplied together all over 32, choose 6. All right, so that's going to be my combination. Now, either way is fine. Either way that you want to do it is fine. Me, I think with the advantage of the calculator, I would use the bottom one because this ends up being 1,000, sorry, 69,2,864, 10,692,864. That's just a number of ways that I can get 3 rap and 3 R&B together. And this bottom one, 652458240. So I want to take and divide those two. And that's going to be 0.016. So I've got about a 1.6% chance of picking 3 R&B and 3 rap. It's going to be some other combination. So a board game is played with tiles and letters on one side. There are 56 tiles with consonants, 42 tiles with vowels. Each player must choose 7 of the tiles at the beginning of the game. What is the probability that the player selects 4 consonants and 3 vowels? So again, this is kind of using that same idea. So now the probability that she selects 4 consonants and 3 vowels. So you're taking 7 letters at a time. So you want to take 4 consonants out of 56. So it's going to be 56, choose 4. But you've got to do and 3 vowels. And is my big dead giveaway that it's going to be multiplication. And 3 vowels, so it's going to be 42, choose 3. All over, well, I'm choosing 7, 56, and 42 is going to be 98. So here's kind of the way to figure out my probability using combinations. All right, so let the calculator do a lot of this work for you. And let's do it. So if I'm going to take 56, oh, I want 56, math, PRB, 56, choose 4, hit that number, then I'm going to multiply that times 42, choose 3. That's just a number of possible different ways I can get 4 consonants and 3 vowels. I want to divide that by 98, choose 7. So that is my probability I'm going to get 4 consonants, 3 vowels. 0.3047. So that's my probability that I'm going to get. And if it's going to be a big, long, ugly decimal like that, it's a good idea to get 3 or 4 decimal places. So for the next semester, Alyssa is signed up for English, Pre-Calc, Spanish, Geography, and Chemistry classes. If the class schedules are assigned randomly and each class is equally likely to be at any time of day, what is the probability that Alyssa's first classes in the morning will be pre-calculus and chemistry in either order? Okay, so here are kind of my options. Now I could sit here and draw it out, but it's going to be kind of easier for that one. So for the first two classes, I've got two options, pre-calc and chemistry. All right, so for the first two classes, I got two choices. So if I look at first hour, I've got two things that could be first hour, pre-calc or chemistry, out of 6 total classes. Let's see, 1, 2, 3, 4, 5. Sorry. So for first hour, I've got 2 out of 5 choices. For second hour, I've got 1 out of 4 choices. After that, I don't care. 3 out of 3, 2 out of 2, 1 out of 1. This is what I'm after. All right, there's about a very small chance of probability I'm going to do that because this can be pre-calc or chem, and this has got to be the other one. So now if I multiply this, 2/5 times 1/4 is going to be 2 over 20. So that's going to be 1/10. So that's the probability I get pre-calc and chemistry first and second hour in either order. So theoretical probability, experimental probability. Here's the big idea. Theoretical probability is what you think will happen. All right, you're doing your math, you're doing educated guesses. It's what you think would happen. Experimental probability is what actually happens. So if I'm actually dealing cards, if I'm actually flipping 10 coins, it's what actually happens. And the big idea is that if I do experimental probability enough times, it eventually will match up to theoretical probability. In the short run, if I flip a coin 10 times and I get 7 heads and 3 tails, that's not that's not 50-50, but over the course of time, it should even itself out. So if a hand of 4 cards is dealt from a standard deck of cards, what is the probability that all 4 cards are hearts? Is this theoretical or experimental? Well, first off, because I'm not standing here dealing cards, it's going to be theoretical. So all 4 cards are hearts. Once again, for those of you guys who forgot, there's 13 cards of each suit in a deck of cards. So kind of one way to think about this is that the probability of me getting a heart the first time is 13 out of 52. But then I take out a heart and take out a card. I do it again, and I do it again. So the probability of me drawing 4 straight hearts would be that multiplied together. But realize, guys, is this. This is nothing more than a combination of 13 choose 4 over 52 choose 4. So it's got to be that. All right, so back to the calculator. 13 choose 4. Whoa, don't do that. Delete. Choose 4 divided by, I always like to put it in parentheses just so I don't screw anything up, 0.00264. There's my probability I draw all hearts. So 2 dice are rolled. What's the probability you will roll a sum of 5? Is this theoretical or experimental? So a sum of 5 is kind of anything that you're going to do. This is going to be theoretical again. Why? Because I know that I'm not actually rolling dice. So when you roll a dice have 6 sides. All right, so when you roll 2, that's going to be 6 times 6. So there are 36 total possibilities when you roll 2 dice. So now you got to think about how many different ways can I roll a sum of 5? Well, the first one could say 1, second one could say 4. First one could say 2, second one could say 3. Flip them around, flip it around. So the probability that I roll a 5 is going to be 4 out of 36, better known as 1/9. So there are all my possibilities. All right, so there is my sums, which how many different ways can I get 5? There it is. There we go. So multiple choice. If you choose an answer to this question at random, what is the chance it will be correct? That's funny. So it's a joke. I always guess B because B is right more often than C is. That's actually been studied and it is correct. Thank you for playing. We will talk to you in class. Play around with both of these. If you need help with the calculator aspect of it, please allow me to help you. And we will talk to you.